This is going to be a run through and demonstration of Busroot, our real-time performance monitoring platform for manufacturers. Essentially what Busroot does is collects real-time information or data from the shop floor, combines that with certain master data such as scheduling information and information related to the SKUs and components that manufacturers make, and present that back in essentially an online web-based platform that manufacturers can use to track progress. The overall kind of structure of the data for Busroot is we have an account level, obviously an account that the customers can log into. Within that, they can have various plants. So you can see here in the top right, currently I'm in our demonstration, but I'm in our London plant. So they can change different plants there if they do have multiple sites and facilities. Within that, we have a grouping that we call station groups. So these are workstations. These can be machines or these can be kind of human-led operations. So if it's an assembly desk or something like that, that's all fine. We bring all of the data in, whether it's from a human-led operation or whether it's from a machine. We bring it all in onto one platform, and I'll go into a bit more detail about kind of how we collect data from those different areas a bit later on. But we have these station groups. So here we have assembly, engineering, painting, welding. Again, this is demo data, but it's kind of representative of a typical structure we will get from some of the manufacturers we work with. Within this cockpit view, we understand the stations that are running and not running. So we have a workstation status that we track. Again, I can go into how we determine whether a station is running or not in a minute. We have the work order that they're currently working on. We have the SKU or component that they're currently working on according to the production schedule. We have the cycle time of the component, so we know the estimated end time. Simple maths of just remaining components multiplied by the current cycle time, and that will give you an estimated end time on that. That comes through in various dashboards that we provide as well. And the quantities. So we are tracking production counts and production quantities live off the shop floor. We can do that automatically directly from the stations themselves, or from the equipment, from the machines themselves, or using things like tablet devices for human-led operations, where the operators can input into the tablets their current production count running through. So that's the station groups. You can see here we have something in red here. So this is acting kind of like an and-on board where we're able to see a station that has stopped, and we'll get into what that means in a moment. Here we can see that there is a station with no schedule, so it's just coming through as gray. So again, we'll take a look at that scheduling section in a minute. So this is a typical view that a kind of an admin or a manager would use on their on their laptop, essentially. We also have dashboards, so production progress dashboards. In this particular example, everyone's almost completed their production orders, but essentially what we're looking at here is for each station, the current work order or production order that they're working on and how close they are to completing that. So you can see these top two have actually gone over their anticipated quantities, and some of these are remaining. As new production orders come in, they will come in at the bottom, and as the workstation kind of completes an order and selects a new work order to work on, that will then come to the top. So this is designed to go on a TV on the shop floor or in the management office, to give a kind of a TV level overview of what's happening. Like I said, kind of similar to an and-on board, but showing you more about production. Real-time production tracking as well. We do have a roll-up on the work order under a work order as well. So across stations, if you have multiple stations working on the same work order or production order, we can roll up across that work order so you can see how close you are to completing actual work orders as well. Just to continue on the production side, we have real-time daily production counts. This is live in real time, so it's showing you the production in this case 30-minute increments. You can filter that down by individual stations if you only want to look at what a station has produced, or you can filter down by components or SKUs so that you can again just see the real-time overview of production happening on the shop floor. Again, we can slice and dice that by station, by SKU. We have overall views that will give you it by station across the week or by SKU across the week. So different ways to be able to get to that production data. As we know, a lot of our customers will use that to kind of inform ERP systems or other third-party systems. We can create API direct syncs between this data and the ERP system, for example, or a lot of our customers will download some of this data as CSV so that they can slice and dice or manipulate it themselves. So just coming back to the cockpit, I'll move on to the next kind of key feature of Busroot, which is automatic downtime capture. So we have various ways of determining whether a station is running or not. That can be based on the production output. So if we have, if we have a device in the machine that's actually monitoring the production count directly, and that production hasn't been seen for a certain threshold related to the cycle time, we can automatically determine that the machine is stopped. We can do it based on line speed, so we can monitor continuous manufacturing processes, and if that line speed drops below a certain threshold or stops again, that can trigger a stop. And it can also work with the human-led operations via the tablet. So again, a similar concept. If the tablet hasn't been interacted with or production hasn't been input through by the tablet in a certain amount of time, then again, that will flag the station as being stopped. What that means is it'll appear here on the cockpit as stopped. Anyone who has flagged themselves to receive notifications for either this individual station or this station group or this plant would receive a notification to say that this station has stopped, and the tablet device on the outside of the workstation itself will also come up with a flag to say that production has stopped here. So if I just go over to the tablet view briefly, I'm looking at this on my laptop, so it's not going to quite look as it does on the tablet, but this is our tablet interface, and this is the kind of thing that would pop up on that tablet to say or to inform the operator that the production has actually stopped. Here we have a bit of a workflow that we kick into. We call acknowledge, estimate, escalate. So this serves as a data capture tool to understand why the downtime has occurred, but also as a communication tool for other people. So anyone else that's received a notification this machine has stopped, when they come to this issue, either via the desktop version of the software I showed earlier, or via their mobile phone, or via a tablet device like this, they will actually, if I acknowledge this as the operator, you can see here it says issue acknowledged by myself, and anyone else arriving on this will know, without having to go and ask anyone, that this issue is being looked at, because it's telling us here the issue is acknowledged. From here, we can do things like estimate the time to get this back up and running. So if this is a maintenance issue, or this is something that's going to require a little bit of time to get back to, we have the estimate function. Again, serves as a communication tool. It also serves as a tool to automatically escalate if that estimate has gone over. Escalate essentially just means it's going to inform a wider group of people. So in the notification preferences, you can select to be whether you just want to be notified of any stops, or if you only want to be notified about escalations. So it'll be a wider group for the escalation. So I can either hit that button, which will automatically trigger the escalation, or if the estimate goes overrun, or if it is not acknowledged in time, all of these things will trigger an automatic escalation. If I then just click cause, this is where we can now give a cause code for this particular issue that we're seeing here. If I select mechanical breakdown, you can see here we have a second tier to the menu. This is customizable, so whatever the customer wants in here in terms of their reason codes, they can fill in here, and it's there's no limit to the number of layers you can have in here. So if you had electrical breakdown and then you wanted another layer within here, you can keep going down categories, because we have a lot of customers that want simple top level items for reporting purposes, so that they know mechanical versus electrical versus staff issues versus stock issues. But then when they go into that, they'll know for this particular machine, it has a certain type of electrical issues that can cause problems. So I've just selected blown fuse there just as an example. What it's done is it's taken me back to the normal tablet view where we can input production. I won't go into that at this point, but just to say that we have now given a cause code for that. And you can see now on the cockpit it's gone amber, just to say that the machine is stopped, but we now have an estimate for it, we now have a reason, it's been acknowledged, so it's in a slightly better state than what it was, because we know that now this is on the path to coming back up again. So if we look at the OEE analysis side of things now. So getting into the metrics of where that comes through in the system, we have unknown time here. That is all downtime that's been captured where we haven't yet had that cause code selected. You see the blown fuses here. So we've taken some of that unknown time and we've assigned it now to blown fuse so that we can continue this process. So, this is again demo data. So let me just go through now and we're looking at the desktop version of the screen I was just looking at earlier on the tablet. If we now go through here and select some different reasons for some of this downtime, just so I can get it all assigned. This is really the key part of Busroot, is to be able to drill into and assign where this downtime is occurring. If we now come back to the OEE chart, you can see that all of that unknown time has now started to be assigned to these different reason codes. So you get this Pareto curve almost of downtime reasons that you're seeing here. This screen will also give you details on schedule loss, maintenance loss, and what we're looking at here is the downtime loss. So where that comes from is the scheduling tool, which I'll just move on to now, because it's kind of a key component of a lot of the way the Busroot works is maintaining this production schedule in the system. It's worth noting that Busroot isn't designed to be kind of a hardcore production scheduling tool, but it does have a basic schedule management system in here so that we can assign work orders to stations for quantities and times. And that gives us a lot of the information we need, the information that we're showing on the cockpit regarding what the machine is working on, the information that appears on the tablets. It all kind of comes from this schedule management piece. So it's an important aspect of the Busroot platform. We also have the ability to add maintenance schedules. In this demo version, I don't have any maintenance schedules in here, but if we were to add them in there, they would appear here as maintenance losses. They would come through in here, and they would also come through on various other charts to just let the user know where that maintenance time is. So in the production schedule here, we have the station, we have the SKU that they're working on. The SKUs are managed separately down here in the SKU management section. So in the SKU management section, we have the code, the SKU code, the SKU name, and also a cycle time. So the estimates are all based off the cycle time. The automatic downtime detection is based off the cycle time. So you can see here, the user either adds SKUs manually or can upload in bulk using something like Excel. We can upload all the SKUs into the system, and then those SKUs become available to select as part of the schedule management tool. There's a few nuances in here. We have individual SKUs or SKU groups. SKU groups allow single cycles of the machine to produce multiple and different SKUs. So an example of this would be a CNC machine, which we work with quite often with our customers. So a CNC machine, a single operation of the CNC machine will actually produce multiple parts, but also multiple types of parts. So different SKUs can all come from that single cycle. So if you set up a SKU group, the SKU group would essentially become the CNC nest code that dictates what program is being run on the CNC. Within that group, you can put all of the subcomponents inside of that group. So when that CNC completes a cycle, we know all of the subcomponents that were produced as part of that, and they will all appear individually under the production by SKU table, for example. Okay, so I'm going to leave it there in terms of this demo. I think I'll split this video up because it's already getting quite long. In the next one, I'll go into asset utilization, line speed, and energy.